To create a manual override switch for a standalone photovoltaic or PV-powered well pump, firstly, install a single-pole, double-throw, or SPDT switch next to the well pump control panel. Secondly, wire the well pump as follows. One terminal of the switch will connect to the line terminal on the well pump control panel. The other terminal of the switch will connect to the load terminal on the well pump control panel. Thirdly, connect the common terminal of the switch to the output of the PV system, which is the positive terminal of the battery or inverter. Fourthly, connect the neutral terminal of the well pump control panel to the neutral terminal of the PV system. In normal mode, when the switch is in the off position, the well pump will operate automatically based on the PV system's power generation. In manual override mode, when the switch is in the on position, it will bypass the PV system and directly power the well pump. This allows manual activation of the well pump and filling of the cistern during the day. Use a switch and wiring rated for the amperage and voltage of the well pump. Ensure the switch and wiring are protected by an appropriate circuit breaker or fuse. Label the switch clearly to indicate its function. It is important to use appropriately sized conductors for the well pump circuit. Refer to the National Electrical Code, or NEC, Table 310.15. The 16 for ampacity of insulated conductors rated up to 600 volts. This table provides the allowable ampacities for conductors based on their insulation type and ambient temperature. When selecting the conductor size, consider the voltage drop in the circuit. Excessive voltage drop can cause the well pump to operate inefficiently or even fail. A general rule of thumb is to limit the voltage drop to no more than 3% from the source to the farthest point in the circuit. The formula for calculating voltage drop is voltage drop equals 2 times the length of the conductor in feet times the current in amps times the resistance of the conductor per foot divided by 1000. You can find the resistance of different conductor sizes in NEC Chapter 9, Table 8. When installing the wiring for the well pump, be sure to follow all applicable codes and regulations. This includes using the proper wiring methods, such as running the conductors in conduit or cable, and properly grounding the equipment. Proper grounding is essential for safety and helps to prevent electrical shock. According to the NEC, grounding electrodes must be installed per NEC section 250.50. Also consider using a ground fault circuit interrupter, or GFCI, for the well pump circuit. A GFCI is a device that detects ground faults and quickly disconnects the power to the circuit, helping to protect against electrical shock. GFCI protection is required for certain locations, such as those near water. When connecting the override switch, make sure to use proper wiring techniques. This includes stripping the insulation from the conductors without nicking or damaging the wires, and making secure connections using wire connectors or terminals. Loose or corroded connections can cause overheating and electrical hazards. Labeling the switch clearly is important for safety and convenience. The label should indicate the function of the switch, such as well pump override or manual/auto. This will help prevent confusion and ensure that the switch is used correctly. The voltage of the PV system should be compatible with the voltage requirements of the well pump. Ensure that the inverter, if used, is sized appropriately to handle the well pump's power consumption. Consider the starting current of the well pump, which can be several times higher than its running current. In some cases, a soft starter may be needed to reduce the starting current and prevent overloading the PV system. Regularly inspect the wiring, connections, and components of the well pump system. Look for signs of damage, corrosion, or loose connections. Repair or replace any damaged or worn parts promptly. A well-maintained system is more reliable and safer. Also, consider adding surge protection to the well pump circuit. Surges can damage sensitive electronic components in a pump and control system. A surge protective device, or SPD, can help to protect against voltage spikes caused by lightning or other electrical disturbances. When selecting a well pump for use with a PV system, choose a pump that is energy efficient and well suited for the application. Consider factors such as the well depth, pumping rate, and head pressure. A properly sized and efficient pump will minimize energy consumption and maximize the performance of the PV system. If the PV system includes batteries, ensure that the battery bank is sized appropriately to meet the well pump's energy needs. Consider the pump's daily energy consumption and the available sunlight hours. The battery capacity should be sufficient to provide backup power during periods of low sunlight. Properly maintain the batteries according to the manufacturer's recommendations. This includes checking the electrolyte level, cleaning the terminals, and equalizing the charge periodically. Proper battery maintenance will extend the lifespan of the batteries and ensure reliable performance. For standalone PV systems, a charge controller is essential for regulating the voltage and current from the PV array to the batteries. The charge controller prevents overcharging and extends the life of the batteries. Choose a charge controller that is compatible with the battery type and voltage. When installing the PV array, follow the manufacturer's instructions and all applicable codes and regulations. Ensure that the panels are properly grounded and securely mounted. The array should be oriented and tilted to maximize sunlight exposure. The wiring from the PV array to the charge controller should be properly sized and protected. Use appropriately rated conductors and overcurrent protection devices, such as fuses or circuit breakers. Consider using a disconnect switch between the PV array and the charge controller for safety and maintenance purposes. Also, it's wise to perform routine maintenance on the well pump itself, as outlined by the manufacturer. This might include checking the pump's impeller, motor, and seals. Regular maintenance can prevent costly repairs and extend the pump's lifespan. If the well pump system is located in an area subject to freezing temperatures, take precautions to prevent the pipes from freezing. This may include insulating the pipes, using heat tape, or installing a freeze-proof hydrant. When designing the well pump system, consider the water quality. If the water is corrosive or contains high levels of sediment, take steps to protect the pump and piping. This may include using corrosion-resistant materials or installing a filter. Also, think about incorporating a pressure tank into the well pump system. A pressure tank stores water under pressure, which helps to reduce pump cycling and maintain a consistent water pressure. This can extend the life of the pump and improve the overall performance of the system. When selecting a pressure tank, choose a size that is appropriate for the well pump and the water demand. Consider the drawdown volume of the tank, which is the amount of water that can be drawn from the tank between pump cycles. If the well pump is located in a noisy environment, consider installing soundproofing materials to reduce the noise level. This can improve the comfort of the occupants and prevent disturbances to neighbors. Also, think about incorporating a monitoring system into the well pump system. A monitoring system can track the pump's performance, such as the water flow rate, pressure, and energy consumption. This can help to identify potential problems early and optimize the system's performance. When selecting a monitoring system, choose one that is compatible with the well pump and the PV system. Also, consider the communication options, such as local display, remote monitoring, or data logging. If the well pump system is located in an area with frequent power outages, consider installing a backup generator. A backup generator can provide power to the well pump during a power outage, ensuring a continuous water supply. When selecting a backup generator, choose one that is sized appropriately to handle the well pump's power consumption. Also, consider the fuel source, such as gasoline, propane, or natural gas. The 2017 NEC Section 690 covers solar photovoltaic, or PV, systems. In Article 690.12 it speaks about rapid shutdown of PV systems on buildings. PV system circuits installed on or in buildings shall include a rapid shutdown function to reduce shock hazards for firefighters. PV systems with alternating current modules and microinverters are compliant with 690.12 and do not need any additional rapid shutdown equipment if they meet the voltage and controlled conductor requirements. Also consider having a licensed electrician inspect the well pump system. A qualified electrician can verify that the system is installed correctly and safely, and that it meets all applicable codes and regulations. An electrician can also provide valuable advice on the operation and maintenance of the system. Regular inspections can help to prevent problems and extend the life of the system. Also, NEC Article 690.31e covers the use of raceways for PV source and output circuit conductors. PV source and output circuit conductors shall be contained in raceway, cable trays, cable assemblies, or conductors listed for outdoor use. PV system DC circuits located on or in buildings shall be installed in metallic raceways type MC cable or where exposed shall comply with 690.31G where the voltage to ground is greater than 30 volts. Furthermore, there are also more advanced override systems that you could use with a microcontroller and relays. This setup could allow for programmable timers to make use of the well pump and cistern at specific times of the day and also to prevent the pump from overfilling the cistern. With this setup, you will also need to provide a way for the system to sense how much water is in the cistern. The microcontroller would take this data into account and then decide when to turn on the pump. This could also be integrated into the PV system's data, and the microcontroller could prevent the pump from turning on if the PV system is not providing enough power at that time. These safeguards can further improve efficiency and safety and provide even more ease of use for the homeowner. When working with electricity, always prioritize safety. Energize circuits before working on them, and use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician. The override switch should be readily accessible to the homeowner for easy operation. Consider the location of the switch and ensure that it is convenient and easy to reach. Make sure the location is also protected from the elements such as rain and sun. This will help to prevent damage to the switch and ensure reliable operation. Remember to consult the manufacturer's instructions for all of the components used in the well pump system. This includes the well pump, the PV panels, the inverter, the charge controller, and the batteries. The manufacturer's instructions will provide valuable information on the proper installation, operation, and maintenance of the equipment. By following the manufacturer's instructions, you can ensure that the system operates safely and efficiently. Additionally, consider the local climate when designing the well pump system. If the area is prone to extreme temperatures, take steps to protect the equipment from damage. This may include using insulated enclosures or providing ventilation to prevent overheating. Also, if the area is prone to high winds, ensure that the PV panels are securely mounted and can withstand the wind loads. This will help to prevent damage to the panels and ensure that they continue to operate properly. It is always important to verify the correct wiring using a multimeter after the installation of the system and before applying power. A multimeter can check for continuity, voltage, and current. This will help to ensure that the system is wired correctly and that there are no shorts or open circuits. When using a multimeter, follow the manufacturer's instructions and take appropriate safety precautions. Do not assume the wiring is correct just because the system seems to be operating properly. It is important to verify the wiring with a multimeter to ensure that it is safe and reliable. Consider adding a water level indicator to the cistern. A water level indicator can provide a visual indication of the water level in the system, making it easy to monitor the water supply. When selecting a water level indicator, choose one that is compatible with the cistern and the water quality. This will help to ensure that the indicator operates accurately and reliably. If you are using a submersible well pump, make sure that the pump is properly supported and protected. Submersible pumps are designed to be submerged in water, but they can be damaged if they are not properly supported or if they are exposed to debris. Consider using a well screen to prevent debris from entering the pump. Also, make sure that the pump is suspended from a strong cable and that the cable is properly secured. This will help to prevent the pump from falling to the bottom of the well and being damaged. Also, NEC 690.4b discusses the equipment listing requirements, which states that photovoltaic equipment be listed and labeled for its intended use. This ensures that components used in the system meet specific safety and performance standards, enhancing the overall reliability and safety of the installation.